So we've already seen some really interesting examples of how we're feeling the effects of climate change from Stuart and from Mark. What I want to do is delve deeper into some of the climate science, but also how we might use that science, how you might use that science. The world is now more than 1.1 degrees Celsius above pre-industrial levels. This chart is showing temperature records from a number of research institutes around the world, including the Met Office. You can see in this chart that 7 of the warmest years on record have happened since 2015. Now, this is the global average. When it comes to impacts, what really matters is what's happening where you are, and also what changes happen in terms of extremes. We've seen increases in high temperature extremes over most of the planet. We have seen increases in the intensity of rainfall over large parts of the planet. And we're starting to see an emerging signal in drought severity and duration. In many of these, we can detect a human fingerprint. We've also seen increases in sea level. Sea level is now rising at more than 3.5 millimeters per year. We're also losing sea ice. Arctic sea ice has declined at around 13% per decade if we look at the September minima. So these changes are happening. We've been out, we can measure them. What of the future? Well, at the moment, we don't know what the future will be because the amount of climate change depends on the emissions, and we get to choose how much we emit. This plot on the left is showing 400 different views of the future. It's showing the carbon dioxide emissions for each of those futures. The futures differ in terms of policy, in terms of technology, in terms of behavior, in terms of trade. All of those things that we think of in the real world that affect the future, we try to build into these scenarios. And what we've done here, we've color-coded those futures that limit warming at the end of the century below 2 degrees in blue, and those futures that limit warming below 1.5 in green. 1.5 is the target within the Paris Agreement many of you will have heard of. Now let's think of some of the choices this depends on. So some of these are personal choices. Some of these are organizational choices. For instance, how do we produce our power? Fossil fuels or renewables? When it comes to domestic decisions, do we go down the route of gas heating systems? Do we use heat pumps? Do we use more solar panels? When it comes to travel, how much travel do we do? And do we switch to electric vehicles more rapidly? There are even implications for diet, and these are all personal aspects of the choice. Governments also play a major role, and I suspect almost everybody in this room will have seen in the news last year that the UK hosted the COP26 conference in Glasgow. Some of you may even have been there. It was really exciting. People from around the world came together to discuss what future commitments might be to limiting emissions. When we add up those commitments from government, they take us part way towards that 1.5 degree target. So 1.5 degrees is still possible, but at the moment, the pledges take us towards around 2.5 to 3 degrees. And what this means is we need to plan to be resilient to a wide range of future climate outcomes. So climate science, it's moving on. It's had a history of defining the problem. Where it's moving to is helping with the solution, providing information that is local to you, information that focuses on metrics that are relevant to you, information on extremes. One of the ways we're doing that in the UK is through the UK climate projections. This was a project we led. We started releasing these in 2018, and we've been adding to it ever since. This is what we refer to as the UK CP18 wheel, and it summarizes the different tools and data sets available. I'm just going to pick a couple of these, the ones that are most often used. If we look at 11 o'clock on the wheel, we have the probabilistic projections. We use those to bound the problem, to get an idea of the range of outcomes. If we move around to 1 o'clock, we have the global projections. So here we can see how the climate change happens over all parts of the planet. We can think about impacts that might be imported back to the UK as well using that tool. And then we come round to 3 o'clock, and we have regional and local projections. So here we're zooming back in on the UK, going down to spatial scales of 12 kilometers or even 2.2 kilometers in the local simulations. When we look across all of these products, we find the headline message for the future, so the one-sentence version, is a greater chance of warmer, wetter winters and hotter, drier summers. What does that mean in terms of numbers? We'll focus first on temperature and temperature increases. This is important from an impacts perspective. It has impacts on people, for instance, through productivity or well-being. It has impacts on nature, and it has impacts on infrastructure, for instance, transport and energy, and in fact, many other sectors. These two plots are showing two of the alternative futures. So in blue, we're showing one of the lower emission futures, where we peak greenhouse gases and then reduce fairly rapidly. And this is showing the temperature outcome for the UK in future decades. Now, there's a range of certainty. You can see that in the shading. But in terms of the central estimate, it's around 1 degree increase from the end of the last century. If we look at the high emission case in red, then the increase now in a central estimate is around 4.5 degrees, but could be as high as 7. And this is the annual mean change. Extreme changes will be on top of this. If we look at water, well, we know that too little water causes drought, but that has knock-on effects, for instance, on food supply or on subsidence. Too much water, and that causes flooding. And what we find when we look into UK CP18 is that in the summer, the top row of plots, there are big reductions in the amount of rainfall. In winter, there are big increases in the amount of rainfall. And if we take the most extreme cases, these changes can be of the order of 40 to 50%. So these are really big numbers. And this has profound implications for how we manage water in the UK going forward. Now, one of the most exciting parts of UK CP18, certainly for me as a climate scientist, but I hope also for you, because the applications from this, the potential is massive. You see weather forecasts on the TV, and for that, we run our most detailed model, just a few kilometers in resolution. But we only run it for a few days ahead. What we've done here is we've run it on climate scales. We've run it for decades ahead to understand what the future climate will be like. And what that means is we're now able to look at information below the daily timescale. We're able to look at extremes in a much more physically credible way. And it helps, for instance, if we're trying to examine the urban environment or how the weather interacts with topography, coastlines, mountains, etc. It gives us a new tool in our armory. So let's look at some results from it. We'll focus on extremes. So the first one is if we focus on a particular type of heat wave, then 50 years from now, under the high emission case, we may see a factor of 16 increase in the frequency of these events. If we look at rainfall, then we'll take the intense events, such as those you might get in summer when there's a lot of convective activity, And here, we're seeing an increase in the intensity of almost 30%. If you remember the previous plot, that's kind of interesting as well, because we're in a summer where we may need to plan for droughts and a lack of water, but there may be days when we have to deal with flooding and too much water. So I'm going to pause at this point to ask you a question. Are you prepared? Are you prepared for extreme weather? Are you prepared for climate change? Are you prepared for the reporting that comes alongside regulation that's linked to climate change? How prepared are you? There was a recent survey of around 2,500 organizations. It took place last year and was funded by DEFRA. And that found that almost 60% of the respondents had already been affected by extreme weather in the last 3 years. The two most common types were heat waves lasting a week or so, or from localized flooding. But only 16% of respondents actually had an adaptation plan in place, although 2/3 are starting to think about it. There is massive potential there to get these plans in place and to do so in a way that is informed by the evidence. So towards that, today, the Met Office is launching the beta version of our climate data portal. And the aim of this is to make it easier to access the climate data and to enable you to add relevance to that data by combining it with your own information. It's a beta version because although we have a lot of information already on it, we want to hear from you. We want to know what needs adding that will make it more useful. And we want you to tell us. So when you go into the portal, you can find out how to do that. Or come to visit us on the expo, the stand in the Partner Expo session. Let's have a look inside. So we're going inside to the front panel. We've clicked on temperature. Now we can select a particular data set. And here we're going for monthly temperatures in the future from UK CP18. You can see the characteristics of the data set on the left-hand side. And now we're going to make a very simple map of that data. And here it is. This is a change over the UK. You can see it's not uniform. You can see some parts of the UK will be experiencing higher temperatures in the future. And you can take this data now, and you can download it if you want. Lots of different formats available. The real power from the data, though, comes from combining it. As an example, we thought we would combine this with information on the rail network. So we're going to look at transport infrastructure, and we can take the map of where the railway lines are, overlay them on top of the future temperature, and that's interesting. We can sort of see where the hazard and the exposure line up. But can we go further? Well, yes, we can. We can estimate the number of adverse weather days on each part of the rail network. That's what you can see here. It builds on scientific work by one of our colleagues at a Met Office partner university, Nigel Arnell at Reading. So now we're showing 3 different periods, and we can zoom in on the southeast of England, where the impacts are largest. And you can see over this area the number of adverse weather days. It's increasing from a near present day period out to the end of the century. It's increasing by a factor of 3 in this case. So this is just one example. Imagine if that wasn't railway lines, but that was the system that is most interesting to you. What could you do with this? What could you look at? A few examples just to start this thinking. Well, it might be that you're an energy company. You want to think about optimizing the supply from renewables. Or maybe you're developing resilient transport networks. Or maybe, like Mark, you're thinking about adapting cities and the urban environment. Or perhaps it's health and well-being. You want to understand how climate will impact that. Or maybe you want to better use the land available to you, need to make decisions. Maybe you're assembling information for reporting. All of those are potential applications, but really, this is only limited by your curiosity and the data that you have available. So let's see where the journey has taken us. We've got Met Office expertise and data, but we've also got your data and expertise and the tools that Esri provides. And in many ways, I think the GIS community is the special ingredient here that's able to make this type of information place-based and bring it into decision relevance. So everyone in this room, you, your families, your organization, will experience climate change. In some cases, you already are. It's not a matter of if, it's a case of when. You have the tools to be able to respond and be part of the solution to this challenge. The question now is, what will you do? The Met Office and Esri are here to help you on that journey. Thank you very much.